Okay, here's another application. It says two banks of a river are parallel, and you can see in the drawing here we have two parallel lines. Between 2 points M and N along the riverbank, so here's our M and our N, is 220 feet, and that's labeled. For point L on the opposite bank, the measure of angle LMN is 44, so angle LMN right there, 44 degrees, and LNM is 32, right there is also labeled. What is the width of the river? So we want to know how far it is from one bank to the other. The hint that they will give you here is to separate this into two separate triangles. And so what we're going to do is notice if the width across the river here is W, it would also be the same here. Since these are parallel, the distance is going to remain the same. So this is also W. Now my issue is I've split this into two pieces. What's the size of each piece down here? Okay, well, one of them I'm going to call X. Okay, the other would be whatever's left over. So let's say this were 10. How would we find the part left over? We would take 220 minus 10. If it were 50, how much is left over for this part? Well, 220 minus 50. Since this is just plain X and we don't know, we know that the leftover part would be the full 220 minus that distance of X. Okay, so what I have here are two separate triangles that I'm going to work with to solve this problem. Okay, I have my triangle on the left side of the figure, which has a height W here, an angle 32 degrees here, and this bottom part is 220 minus X. I also have this triangle on the right. I'll draw it up here. Okay, it had a 44-degree angle, a height here of W, and a distance here of X. They're both right triangles. I'm going to use each with a trig ratio to set up an equation. So for this 32-degree angle, notice we are dealing with the side opposite and the side adjacent. So which trig function uses opposite and adjacent? Hopefully you said tangent. The tangent of an angle is the opposite side over the adjacent side. Let's put in our information that we know. We know our angle. I'm going to write it right here. So we have tangent of our angle was 32 equals the opposite side, which was W, over the adjacent side, which is 220 minus X. Let's do the same for this triangle. Set up an equation. Well, for our 44-degree angle, again, we're also dealing with an opposite side W and an adjacent side. So here we would also use tangent. Tangent of the angle, what was the angle? 44 equals the opposite side W over the adjacent side of X. Okay. Well, we want to isolate. Notice we have W on the top on both of these. If we could isolate the W, that would be great. So what I'm going to do is multiply both sides by X here. That removes it from the denominator and isolates W here as X times the tangent of 44. On this side, it's a little crazier, but doable. I want W alone. It's divided by 220 minus X. So if I multiply by 220 minus X, that will eliminate it from the denominator. And whatever I do on one side, I have to also do on the other. So I have W equals tangent 32 times this. That would give me 220 times tangent 32 minus X times tangent 32. I had to take it times both parts. So basically I just distributed there. Okay, so this is kind of a common theme. This is kind of how we're solving each of them. We isolated one variable. Okay, so we know that W is not only X times the tangent of 44, but it is also 220 tangent 32 minus X tangent 32. Since those are equivalent, they're both W, we can set them equal to one another. So that is exactly what we are going to do. Okay, so we have 220 tangent 32 minus X tangent 32 is equal to our other W, which was X times the tangent of 44. Okay, from here we need to isolate our X's. Well, I have an x on this side and an x on this side. This is subtraction, so if I add x times the tangent of 32, they're kind of connected right there. I can't just move one of them. I have to move that whole thing. And add it here, then I will have my x's all on the same side. And I will then have just 220 tangent 32 on the left side. On the right side, I'll have x times the tangent of 44 plus x times the tangent of 32. You can't really combine those. What I can do is they both have x in them, so I can factor out an x. Kind of the opposite of distributing. You're pulling that value back out. I get x times tangent 44 plus tangent 32, which again is still equal to 220 times the tangent 32. I want to solve for x. It's multiplied by this entire value. So if I divide by that entire value, the tangent of 44 plus the tangent of 32, it will clear out on this side. I have to do the same on the opposite side of the equation. So I'm following those rules of algebra, keeping it balanced. Whew! And there I have x. Okay, so we just found that x is 220 times the tangent of 32 divided by tangent 44 plus tangent 32. And you may have your own preference. At any point you may want to calculate these tangents. I find it's best to do as little rounding as possible, but if you need to, go for it. Okay, calculate these, be really careful. You want to find these tangents individually and then add them together. Find this multiplication and then take the top divided by the bottom. But when you do that, you should get about 86.4. If not, there's a calculation error up there because I've checked and double checked. Okay, so we found x. That was our difference here in our lengths when we split our triangle in two. We want w. We want the actual width of the river. Well, in one of our equations we set up, we know that w is the same as x times the tangent 44. Now that we know x is 86.4, we can plug that in. 86.4 times the tangent of 44 gives me 83.4 about. Okay, so one step at a time, surely, steadily, we came to our answer. The width of the river is 83.4 feet, approximately, of course.